In this section, you'll get a first-hand look at some of the things you'll be both doing and looking for when you get into the field. Really, the energy audit starts the moment you drive up at the house. When you get out of the vehicle, you're going to be looking at the house. You're going to be looking at the general condition of the house, the condition of the roof, the shingles, the gutters, the siding, the windows. As you walk up to the house, you'll be looking at the drainage from the house. Is the dirt sloped away from the house to give us nice, good drainage? When we get up on the porch, we're going to take a careful look at the siding and the condition of the door. After we take care of the paperwork with our homeowner, then we're going to start our walk-around section. As we're doing our walk-around part of our inspection, we want to be pulling our dimensions and making our drawings and making our notes. We're going to take notes of attic ventilation, including our soffit vents. We're going to be looking at the windows, make sure that we have windows that are tight. What kind of condition are the windows in? We're going to be looking at building penetrations. Do we have hose bibs, plumbing penetrations, electrical penetrations, cable penetrations, and are those penetrations sealed? Do we have vents into the house or into a basement crawl space area? We're going to look at drainage, or do we run across any kind of drainage issues? We're going to be looking at our downspouts. Do the downspouts take the water from the gutters and take it away from the house, or do they drop it up against the foundation? Really, what we're looking for is anything that's going to affect the way a building uses energy. As we walked up onto the porch, we noticed this transom window up above the front door. Now, it's painted over, so they're really not getting any light through it. And it really looks like a single pane of glass. So they're probably going to be losing a lot of energy through it as well. So when we get inside, we're going to really want to pay attention to what's going on with that. When we were doing our walk around, we ran across this flue pipe with a long run outside exposed to the elements. What that's going to do is cause an excessive cooling of the combustion gases. So likely when we get inside, we're going to find a water heater and a furnace that are having a hard time drafting. When we do our walk around of the house, we want to pay particular attention to changes in the roof line. A change in the roof line could indicate an additional phase of construction. When we have an additional phase of construction, that could mean different building materials, different insulating materials, and ultimately a different way that that building uses energy. In this house, we see a change in the roof line as we get toward the back door. That change could indicate that that area at the back that looks like a porch is an additional phase of construction. So when we get inside, we'll want to pay particular attention to the building materials and the insulating materials in that part of the house. So when we look at the stucco, we can actually see there's no insulation back behind it when we look through this hole. The stucco is right up against the sheeting. There's no insulation in between the sheeting. It's just the scratch coat and the finish coat. Now that we're done with our exterior inspection, it's time to go inside. But before we go inside, there's a couple of things we want to keep in mind. First off, we always want to show courtesy to the homeowner by asking them if it's okay if we wear our shoes. The second thing we want to keep in mind is that we are here to evaluate the homeowner's energy usage and not their lifestyle. So we always want to be careful to keep our comments about the homeowner and the homeowner's home to ourselves. So we're going to start the interior inspection section of our audit. That starts right here at the front door with this storm door. So when we take a look at this storm door, right now it's set up in summer condition. It's got the screen at the top and the glass at the bottom. And that's fine if we're in the middle of summer. But if we're in the middle of winter, we want to make sure that this storm door is set up in winter condition with glass above and glass below. The next thing we want to take a look at is the weather stripping for the main door. We want to make sure, first off, that the weather stripping is here. Make sure that it's in good shape and that it's not cracked and it's still soft to the touch. The next thing we want to take a look at is our main door. What is it made out of? Is it in good shape? If it's wood, metal, making sure it doesn't have any cracks or openings or leaks. The next thing we want to do is to shut that main door and check to make sure that we have a nice good seal going all the way around. Now we also notice that we have something hanging over that front door. And what that's going to do is that's going to compress that weather stripping on the inside. And when we run our blower door, likely we're going to see some leaks up there. Up above, we see this transom window. And so it's confirmed, right? We just have a single pane of glass. It's painted over. This area is actually quite dark, so they're not getting any benefit from the light coming in, and they're going to be losing quite a bit of energy out of that window. Down below at the bottom of our door, we want to make sure that we have a door sweep and that that door sweep is installed and in good shape. So stepping away from the front door, we want to make sure that we have a good routine so that we don't miss anything that could be a potential problem. So we're going to come in and go to the left and follow the wall, making notes of everything we run into along the way. The first thing we run into is this window. When we look at a window, we want to look at the window covering to see if it's moving. If it's moving, that gives us some evidence that there may be some air leakage that we're dealing with. The next thing we want to do is take a look at the rest of the window coverings. In this case, we have horizontal blinds. What are they made of? Are they open when they should be shut? Are they shut when they should be open? The next thing we're going to take a look at is the window itself. What is the window frame made out of? Is it single pane, double pane, triple pane glass? We're going to look at where the window frame meets the rough opening and the trim. Are there cracks, which could be an indication of possible air leakage? The last thing we want to take a look at is our window sill and make sure that we check down below the window sill to make sure that that's been properly caulked and sealed. All right, so I'm going to check down underneath the window sill to make sure that it's correctly caulked and sealed. And I am looking down here and I see some cracks and gaps between the windowsill and the trim piece here, which indicates to me that we're going to see some air leakage when we run our blower door test. The next thing we run into are these plants. Now, plants are a source of bulk moisture in a home. So we'll want to keep a particular eye out for issues like mold and other water-related issues. The next thing we run into is this ventilation duct. This ventilation duct is partially obscured by this table and is being rendered only partially effective. So we're going to make sure we want to talk to the homeowner about relocating this table away from this ventilation duct. The next item of interest we arrive at is this lighting fixture. Now, the two things we want to keep in mind when we're evaluating lighting fixtures is, one, how well does the lighting fixture attach to the surface, the wall or the ceiling that it's attached to, and what kind of light lamp is in it. For example, this one has a real nice attachment to the wall and it has an incandescent bulb inside. So that could be replaced by a CFL to improve efficiency. The next thing we run into is the fireplace. Now we saw this fireplace, it was capped outside and we see that there's no opening inside, but we still don't know if it's been sealed properly. So we want to talk to the homeowner and find out, did they have it done or was it like this when they moved in? And then when we run our blower door, we want to make sure that we shoot this with the IR camera to make sure that it's not leaking energy. So before we leave the room, we want to make sure that we check the ceiling for ceiling fixtures. Now, even though we may have a ceiling fan there, we want to remember that the two important things are how well does the ceiling fixture attach to the ceiling? Are there cracks or air gaps there? And what kind of bulbs are in the fixture. The next thing we run into is this outlet that's installed on the floor. Likely this was done because it was installed after the building was built and because there wasn't any room in the wall to run wires. Yep, that's solid masonry. So we want to make sure that we check a couple of these supply registers. We simply take the grating off and look down into the ductwork. When we look down into the ductwork, we want to make sure that we check for debris that may have fallen down in there, foreign objects, as well as checking with how well the ductwork attaches to the subfloor. If we don't have a good connection between the ductwork and the subfloor, we can get cold air coming in from an unconditioned space, even bringing in unknown contaminants into the house. From here, we're going to continue throughout the house, looking at all the windows, checking to make sure they're closed and locked, checking for cracks, checking windowsills, checking registers, and so on. Behind me is one of the double-edged swords of energy efficiency. It's the whole house fan. And a whole house fan during the summer can save the homeowner a ton of money. But in the wintertime, it can be a source of tremendous air leakage. This homeowner also has a programmable thermostat that allows them to program a different temperature for different times of the day. So in the wintertime, they can keep the house cooler when they're not home, allowing them to save both energy and money. When we evaluate washers and dryers, when we look at the washing machine and we want to know, is it front load or top load? Does it have an Energy Star logo? When we're looking at dryers, we want to know, is it front load? Is it top load? What kind of fuel is it running on, whether it be electric or gas? Does it have moisture sensing? What does the dryer vent duct look like? So in this case, we have a moisture sensing electric dryer on top of a Energy Star front load washing machine. Now, when it comes to washing machines and dryers, when we make a recommendation to a homeowner, if that homeowner washes clothes 2 or 3 times a day, then it would be valuable for them to upgrade to units like these. But if they're only doing 1 or 2 loads of laundry a week, then it's probably not going to be profitable for them to upgrade until one of those units breaks. Dishwashers don't use a lot of energy to begin with. So when we examine a dishwasher, we want to look for the Energy Star logo. If we don't see the Energy Star logo, then we want to recommend to the homeowner that when they replace their dishwasher, they replace it with a model that's the most energy efficient at the time that they can afford. Because our refrigerator is part of the electrical base load, it's very important that it be as efficient as it can be. So when we examine our refrigerator, if we're not metering it, we want to make sure that we look inside at the label and pull the model number and the make, as well as looking for the Energy Star logo. So the next thing we're going to look at is the microwave. Now, the microwave, we want to check to see if it has the Energy Star logo. In this particular case, this microwave doesn't. We also want to check if that microwave is sitting above the stove to make sure of the venting, whether it's vented outside or back into the house. Now, down below the microwave, we have an electric stove and oven. This electric stove and oven also doesn't have the Energy Star logo. So we would recommend to the homeowner that when they replace this stove and oven, that they replace it with the most energy efficient stove and oven they can afford at the time, or they can switch to gas. We only want to recommend that they switch to gas if the kitchen exhaust vents to the outside. How do we know if it vents to the outside? We take a look above the vent hood to see, and in this case, we don't have any ducting going to the outside. So for this particular homeowner, gas is an option because it is here in the house, but we only recommend a switch to gas if they're also willing to add venting to the outside and use it while they're using their gas stove and oven. When we were outside, we noticed a change in our roof pitch. When we got inside, we discovered that the kitchen is an addition from the main structure. So we want to make sure that we check our wall construction and insulation levels. On our south wall here, we still have masonry construction. But on the west wall, we have drywall that has appeared to be furred out from our masonry construction. So we want to do a little more investigation here to see if we can add insulation to this wall and improve its R value. As we come down into the basement, there's a few things that we're going to want to be looking for. We want to look on the floor and see if we see any evidence of water, standing water, or water that it's been there. That would be an indication that there could be some drainage issues or a leak going on. We don't see any evidence of standing water or water damage, discoloration. So really, this floor looks good. We also want to take a look at wall insulation for the basement, as well as rim joist insulation in the basement. And then we want to take a look at the furnace and the water heater and the associated ductwork. Here behind me, we have ductwork for the furnace. You'll notice that this ductwork has quite a few twists and bends in it. And what that does is that restricts airflow. So we probably want to have an HVAC technician take a more careful look at this and see if something can be done about that. We also notice on our flue pipe for our water heater and our furnace, we have this metallized tape. And we shouldn't have metallized tape or duct tape or mastic anywhere on our flue pipe. And after this Y, we should have double-walled B-vent going all the way out of the house, all the way up to the spark arrestor outside the house. This is the cold air return, and the installer has decided to use the space in between the joists to help make this return. But you'll notice that it's not sealed very well. It's got gaps on the outside. So those also should be sealed with duct mastic. One of the things the homeowner mentioned is that the basement tends to be significantly warmer than the rest of the house. So even though the basement is conditioned space, we would recommend that the supply ducts be insulated to get more of the heat from the basement into the main part of the house. When we look at our basement walls, we're noticing quite a few problems. First, we're not seeing any insulation on the foundation walls. In addition, when we're seeing pieces of our foundation wall that are missing, we can see exposed dirt on the other side. And in that exposed dirt, we're seeing discoloration where water has come in and is probably building up behind the foundation, maybe even displacing the foundation. You notice this rust spot here? This is evidence of what we suspected outside, that the furnace and the water heater are having difficulty drafting. What happens is when the water in the combustion gases begins to condense, it pools and starts to rust the flue pipe. We also notice at the end of that flue pipe, it's not very well sealed. So likely we have some air coming in to the building around that flue pipe. Now we're going to do a general inspection of our furnace and water heater. We're going to grab our list to make sure that we catch everything. And then the first thing we're going to do is look around the furnace and water heater. Make sure there's no trash or combustibles like gasoline or paint or anything like that. Then we're going to shut down the appliances. Make sure that we identify the appliances. In this case, we have a standard water heater and forced air furnace, 62% efficient water heater, 70% furnace. We're going to check the flue pipes. Do we have any problems with the flue pipes, like they're not attached properly, we see rust and that sort of thing. Next, we're going to take a look at the draft diverters. Does the draft diverter on the furnace, is it free of obstructions? Does it have anything off in there? We want to make sure that that's out of the way. Then we're going to take a look at our gas piping. Do we have any leaks? Then we're going to take a look at the filter, the furnace filter. Has it been cleaned? Does it need to be cleaned? Finally, we'll take a look at combustion air. Do we have enough combustion air coming in from the outside? So this is our draft diverter. We notice that it's nice and clear. We don't have any paper towels or anything stored in this area. So in order to get to the furnace filter, we have to take off both panels, the top panel and our bottom panel. Our filter is going to be next to our cold air return. So when we take a look at that, well, it's not clean, it's a little bit dirty, but homeowner's probably going to want to replace this in another week or two. And then we'll make a note on our report that the homeowner needs to change the filter in the next week or two. Okay, so we're just doing a visual inspection of our gas pipe, looking at all the joints. When we inspect the top of a water heater, we want to look at how the flue pipe attaches to the draft diverter. Is this the proper draft diverter for this water heater? We also want to take a look at the cold and hot water pipes for corrosion, because corrosion can be evidence of drafting issues with the water heater. We also want to look at the P&T, the pressure and temperature valve, make sure it has piping attached to it and that piping runs all the way down to within 6 inches of the floor. And we want to disable the water heater by turning the temperature valve all the way down to vacation. Here we are in the attic. Now we want to keep in mind that when we go into the attic, safety is paramount. You'll notice I have my Tyvek suit on, I have my respirator, and I have my glasses. And of course, we want to make sure that we stay on the studs because we don't want to go through the ceiling. The next thing we want to look at is just the general condition of the attic space. We start at the top, looking at the roof decking. Do we see signs of moisture? Here we see some signs of moisture, but we also see that we have a new roof. So probably there was some leakage and that's why the homeowner replaced this roof. Next, we take a look at our roof vents, just to make sure that they're open. Because sometimes we'll see roof vents from the outside, but when we get into the attic space, the roof vents aren't open. Next, we make our way down to the insulation. What kind of insulation is it? What is the condition of the insulation? And how deep is it? We're going to measure our insulation depth. Here we have about 3 inches of cellulose, so that's going to be about an R10. It's really just chopped up newspaper that's been treated to make it fire resistant. We have 3 inches, so we need another 10 to 11 inches to get this attic up to an R39. Okay, so I'm checking for the air barrier, so I'm digging down through the insulation here until I get to the ceiling. There's the ceiling, and there is no air barrier here. And you might be wondering what this red plastic is. Likely it's simply the bags that this original cellulose came in, and really doesn't mean anything. Next, we look for any signs of air leakage from the conditioned space of the house into the attic. Remember our whole house fan? Well, here it is from the attic side. What the homeowner has decided to do in this case is wrap it with insulation and cover it up with a couple of bats of insulation. And that'll work good at preventing thermal heat loss. But it's not going to do a whole lot for our air leakage, because in between these bats, air is going to get through and easily make its way out of the house. The proper way to do this would be to use rigid foam. We'd build a 4-sided box, seal it at the ceiling, and then put a 5th piece of rigid foam on top, making sure it's well sealed with weather stripping. And then we put something heavy like a brick on top. Then in the summertime, we take the brick off, we take the lid off, and we can turn on the fan and cool the house. Another thing we want to look for in an attic is ductwork. We don't have any ductwork in this particular attic, but if we did, we'd want to make sure that it was properly sealed and insulated. Now it's time for our blower door test. But before we do anything, we need to make sure that our water heater and furnace cannot fire. That's important because our blower door creates a negative pressure inside the house that draws air down the flue pipe that can cause the flame in the furnace to roll out of the cabinet and create a fire danger. We can also pull dangerous carbon monoxide into the house, putting ourselves and the homeowner at risk. So I'm going to go down and turn our furnace off and turn our water heater to vacation. And I'm going to leave my jacket to make sure I remember to turn it back on before I leave. The heart of the blower door is the control and measuring device called a manometer. Now, a manometer measures the difference between pressure inside and outside, but in order for it to work properly, it has to be calibrated. The quick reference guide for your blower door will give instructions on how to do that. I've already done that with this manometer, so we're ready to get started. Now we'll take the cover off the fan, and we're going to depressurize the house to minus 25 Pascal. Now our goal is minus 50, but we're going to stop at minus 25 to make sure that we're not doing any damage to the house. We're going to check to make sure we're not pulling out ceiling tiles and that our fireplace, if we have one, isn't throwing ashes all over the living room. Once we've checked the house, then we'll go ahead and continue to ramp it up to minus 50 Pascal. We don't have to be right on, but we need to be pretty close. Once we get it to minus 50 Pascal, we're ready to check for leaks. But you'll notice that the flow side of our meter is still flashing low. That's because our manometer is having a difficult time getting an accurate reading of the air moving through the fan. So we're going to add a ring to the fan, reducing the diameter, giving us a more reliable reading for this particular house. With our blower door running, we're drawing air in through every crack in our pressure barrier. Every leak we find represents an opportunity to save energy and save our customer money. We're looking at an infrared photo of the attic fan vent and the air leakage around it. We can see that it's showing us 93 degrees about. That's actually the temperature of the air that we're pulling in from the attic. Another common place to find air leaks is where fans and light fixtures attach to the ceiling. Air movement at a register or return is an indication of leakage in the ductwork. This is a good example of a poorly sealed attic access hatch. Not only can you see it with the IR gun, but you can feel it and you can hear it. We see a large gap in this attic access hatch. We don't see any weather stripping or really any seal to speak of. We just have warm air being vacuumed in. This is going to be a major source of air leakage. This infrared picture shows the fireplace. We don't see any significant change in temperature, which is a good indicator that it's been sealed up properly. The front window, and we see a little bit of air leakage coming in at the corner, but nothing really significant. Transom window, we can see a lot of heat coming in through this window, 83 degrees. So in the wintertime, this is going to be a significant source of heat loss, and in the summer, heat gain. This infrared image shows leakage around the front door and around the coat hanger that's hanging over the top of the door. As a building analyst, if we do a thorough inspection of a client's home, we will have the best chance of identifying areas where they can save money and be more comfortable.